Okay, so welcome to the second part of our SOS workshop here at the Inspire conference. As we are aware that some of you didn't attend the first part, we want to give you a very quick introduction what has happened and what we are going to do in the second part now. So in the first part, we had a quick roundtable to get a bit on the background, some welcome, some background information on the project we are working in. It's a project together with the JRC in which we are working on a proposal how the technical guidance for download services could be updated in order to better accommodate also new data types such as observation data. And we went through this proposed update of the technical guidance, how to accommodate a dedicated interface for observation data, especially the OGC Sense Observation Service. We had a look at different approaches, how organizations can set up their Inspire compliant SOS service for sharing their data. And we started with a short demonstration / hands-on how to interact with such a Inspire compliant SOS server. Now for the second part, we will switch the agenda a bit. We will continue with this hands-on part because we didn't go beyond the get capabilities requests. Then we had planned a slot for presentations by participants, but we didn't get feedback on that before the workshop. Is there any one of you who would like to give a presentation? No? Okay, so we will skip that part. And we will continue with some further discussion about your position on SOS, your requirements, what would motivate you to set up a SOS, what are perhaps difficulties you envisage which could block you from implementing that. We will also have an outlook on different client applications you can use, some demonstrations in that part. And then also some outlook and questions from our side. We would like to get you involved in this MIG process, perhaps as technical experts if you are interested in, to ask whether you would be interested and willing to try out this proposed update with the open source implementation or other implementations. That's something which we would like to do for the conclusion. So, for those who did not participate in the first part, we are talking about SensorWeb as a background topic here. SensorWeb is basically an interoperability layer helping you to integrate new observation data sources into existing applications. It's basically an enhancement of existing spatial data infrastructures to better handle sensor data as a new source of potentially real-time but also historic information. For that purpose, we have the OGC SensorWeb Enablement Framework, SWE, which provides different standards for interfaces to request sensor data. That could be the sensor observation service of the OGC, which is also the topic of this workshop. And on the other hand, OGC ISO observations and measurements as a common data model and encoding for sharing and providing observation data measured by sensors or humans in a common way. So that's the technological background. Then we looked at the technical guidelines and tried to map the functionality which is required for Inspire download services to the operations of the SOS. So we have the two groups of functionality in the technical guidelines. The first one, the predefined data set download. There we have on the one hand, the information about getting metadata about the service. That's capabilities like for get capabilities like for all OGC services. Information about getting the actual spatial data set. In this case, the spatial data set means the set of observation data. That's through the SOS operation called get observation. And then further information about describing the spatial data sets, metadata about the data sets that's available also in the SOS capabilities, linking to the download service can be achieved through the catalog service. And then the other part, the direct access download, means you can better subset your data, you can request specific observation data, and there you can again use the OGC SOS get observation operation, because as soon as you have set up an Inspire compliant SOS, you immediately can cover both the complete dataset, the predefined dataset download, as well as the direct access dataset, direct access download, because these filtering options of the get observation operation, which are by default provided by SOS implementations, already allow also this direct access download. So some conceptual mapping, spatial data set, which is the core concept for the predefined dataset download, that can be mapped to the observation offerings in the SOS, which is a tool in the SOS specifications for grouping observations. The spatial object in case of this enhancement would be the observation. So one measurement together with its location, its timestamp, information about the sensor, about the parameter that was measured, and then the spatial object type, that would be the observation type. Observation type can be measurements for scalar values, but could be also textual observations by humans who are reporting some kind of other thing they are seeing. In the technical guidance, we have some enhancements. We are including new mapping rules, what I have already shown, and 2 new chapters for describing how the predefined download as well as a direct access download can be realized through the SOS. For becoming Inspire compliant in the SOS needs to be enhanced by some small additions. That includes, on the one hand, having additional Inspire metadata, and on the other hand, support of the coordinate reference systems as well as the language as additional query parameters which have to be considered. And one message we gave you is that there is a prototype of such an Inspire download service as open source software will be made available to you. And here we have one example. We have data here from 3 different countries, Belgium, Netherlands, and Sweden, air quality data served through the same interface and shown in one client accessing all of these 3 data sources through the same interface. So that's the first part as a summary of the first session. And we stopped in the part where we were interacting with the SOS. And if you would like now to try out a bit in parallel to the demonstration that I'm giving, I could recommend to have a look at this URL. If you type that down, you will get in your laptop a test client, which allows you to send requests to a running instance of such an Inspire compliant SOS, and you can follow me what I'm doing with the this client. You can see how these requests works, how the responses are, and you can also take that with you to home, this URL. That service will run for quite some time, and you can use that also for later on if you want to try out how to interact with an SOS server. So I'm just waiting a couple of seconds so that you can write down the URL. Okay, anyone still typing? Okay. So what I'm showing now is this test client. And this client allows you to select certain SOS requests, how they can be formulated. And for that purpose, you have to go here. You can say, I'm interested in the SOS. You can define the service type, the version, and so on. And you get this drop-down list where you can find some basic request example. And what you should do now is to go to the key value pair, KVP tag, and there for example, get capabilities with CRS. That's one example request that you can call. We can click on this one, and what we get is a request URL that's displayed here, showing how to request this metadata from the SOS. I will show it to you a bit. And what you have here is a typical get capabilities request sent to an SOS server. And we have the service parameter, like in every OGC service. In this case, it's SOS. The request name is get capabilities, and we just add CRS 4258 as the requested coordinate reference system we are interested in. So let's submit this URL to our SOS server. Let's take this one. Bigger. Oops. And what you now get is the metadata of this SOS service. We looked at that also already in the first section, but now we can go to where we have the bounding box at the end is at least 1. So at the end we have this bounding box. Now we have requested the bounding box of the data sets which are available. In this case it's one data set provided by the JRC, and here we have the bounding box in the requested coordinates. We can change that. We can go back to the test client. Okay, so let's select key value pair, get capabilities. Okay, we have to look in the capabilities what else is supported. So let's use this one.
These are the coordinate systems of the service that are you have the requests and the respective responses in those coordinates.
So at the end we just replace the EPSG code, and now we should have the coordinates. In the EPSG 31466 coordinate reference system, because that's something we requested. So you have seen get capabilities. You can execute that with the language parameter and the CRS parameter to get a reply in a way that you can understand, depending on your coordinate system you want to use and the language that you want to use. So, but that's only the first part. The first part, you now have metadata about the service, and the next step would be that you want to get the data itself. And for that purpose, we have the get observation operation. Let's go here in our test client. Let's scroll again to key value pair, KVP. For example, this one. I will show you the URL, what that means. So we are contacting our service, which is an SOS. We are talking to this service in version 2.0. Our request is get observation, because we want to get the raw data now. Then we are requesting data for a specific offering. The offering is something, we go back to the capabilities. So we have requested the metadata from the SOS, and if we go to the content section, you will see that these contents are organized in so-called offerings. Offerings, so the data sets that you have. What you can insert here is One offering, what you can see, time series of air quality data at the JRC, and this is the offering identifier, so the identifier of this data set. And what we are doing now in our request is we are saying we are interested in data for this offering, HTTP, and so on, in German language. So what we do is now we take this request, put that into our browser. Yes, that's... I think the problem is I took the request from the test client. Yeah. Yeah, that should work.
The name of the...
Yeah, yeah, right. So these services have different data sets available, and because the one service did not know this data set that I was requesting, I got this error message. Let's do this one. So now we got back an observation document. But I would like to show you the request that I have sent, because that's now a bit bigger. So that's a bit hard to read. I will do some line breaks in between. So we do a get observation request. We are requesting a specific observed property. So that's the parameter we are interested in. That has the identifier. Here we are pointing to a Wikipedia entry in the sense of, yeah, linking different data sources, linking data information sources. In this case, we are pointing to the entry of ozone. So we are interested in ozone measurements. You can also use other identifiers. However, it is recommended to have some kind of URI to make it resolvable. We have the specific namespace. Then we are applying a temporal filter. Oops, where did I do the break? Let's do it again. So temporal filter for the phenomenon time. Phenomenon time, that's the time for which the data should be applied to the phenomenon. So we would like to have water level data for a specific time period, for example. So we have the phenomenon time in this case. So phenomenon time is here. We have the time period. It's not so nice to read because it's URL encoded. So we have a time period from 2012, in January, the 1st of January until the 5th of January with a timestamp also. Yeah, and then we have sent this request. And now in the browser, you get this response. Also make that a bit larger. And what you can see here is now an observations and measurements document, O&M, as defined by this ISO standard, and also as mentioned in these INSPIRE guidelines on the use of O&M for observation data. What you see here is that you have the phenomenon time. That's the time for one observation when this value has been taken. Result time, it's here identical. The procedure, that's the identifier of our station, here in this case a station at the JRC. Then we have a parameter, that's the named value for the sampling geometry, which is a point. So that's the location where the measurement was taken. So we have the georeference. We have the observed property, which is ozone. So you know what the data is about. The identifier of the feature of interest, the location of the weather station, and the result. In this case, the unit of measurement is parts per billion for the ozone, and the value is 1.1. Yeah, and that's it for one observation. There are multiple observations in this document, and so quite a lot of information. What you may see here is that you have quite a lot of XML for just one single value. There are also other representations in O&M which are more compact. So do not be afraid. This is really one O&M observation type which is suited now to show you the different properties of the file. However, there are much more compact options also to encode that in O&M, that you do not have to do so much XML for just one single value. There's a lot of much more efficient ways also in the standard. Okay, so that's our get observation request. We could also again add other elements like the CRS. Let's see. We can copy this one. So what have we here? We have EPC 4326. We can change that. And now it's loading. And now you get the data in 4258. Yeah. So you get the different CRS for request or showing the data. That's one enhancement of the Inspire SOS, because default SOS do not have this coordinate conversion built in. That's an enhancement for Inspire, like the multilinguality. So that's the way for getting your observation data out of the SOS. Another thing that's quite important is also getting information about the geometries, so the get feature of interest operation. I can also show you this one. Let's do this. I will first show you the get feature of interest. Get feature of interest means you have seen there's a site associated also in the observation document, which points to the station where the measurement has been taken. If you want to find out more information about that location, you can do a get feature of interest request, and that has basically quite simple elements: get feature of interest, language. In this case, we do not even have a filter in there. You would get all features, but we have just one feature in the SOS, so no problem for us. And here you have the feature. What you get here is we have requested that in German. We have a German description, Messstation beim JRC. Identifier, that's the identifier of the station, the code space, the type of the station, it's a sampling point, so measuring data at one single point. The sampled feature is a bit more complex. You can create some relationships with these sampled features, like in hydrology. In hydrology, you have your stations. These stations are at a river. The river may be in a catchment area. So you can use the sampled feature for building such more complex information. You can have a shape. In this case, it's a point where the feature is located. And then that's your information about the geometry. You could add further optional attributes if you want to provide more information. You are quite free to do that, but that's the basic response you can get. And now we can change the language parameter again. So we have GER at the end. We can change that to ITA. And now we are getting the same information in Italian. So of course you have to make sure that these multilingual properties are stored in your database you want to make available. You can also have single language, but in this case, for demonstration purposes, we have made sure that we have descriptions in English, German, and Italian. So that's feature of interest. And then there's one last operation I would like to show you. That's get describe sensor. I will first take this one. Okay, first let's have a look at the request. So what you can see here, I think I will introduce some line breaks to make it more readable. Our request that we are submitting here is describe sensor, and it has one parameter. It's the so-called procedure. Procedure points to the sensor for which we would like to have the metadata. Here we have the URL, Inspire JSC, and so on. So that's the station identifier. The procedure description format says in which encoding would we like to get these metadata. In this case, we are requesting SensorML, and the language we would like to have is Italian. So we have submitted that, and now we have gotten back SensorML document, and there we get all elements of metadata about the sensor which has generated the measurement. And for many scientists, that's quite important information, because depending on the quality of the sensor, they can decide, is it okay to use the certain data for specific analysis, or is it not possible to rely on this data? So we can provide information about the time period for which this information is valid. So you can limit the validity of your metadata. You provide keywords about your sensor, like carbon monoxide, just that people can discover it. So such a SensorML document is basically essential for making a sensor discoverable on the web, because that would be something which is indexed in catalogs to search for observation data sets. So there, SensorML gets a key role for enabling that. So several keywords we are providing. Here we have one keyword where we see we have Italian language, because that has been defined in multiple languages. We can now get this in the requested language. Then we have the identifier of the station, different identifiers, the unique ID. We can have a long name, a short name, intended application can be provided. What you have to keep in mind, most of these fields in the SensorML specification are optional, and we expect that the metadata you have to provide is something not to be defined by the interface specification of the SOS, but that is rather something of the data specification part. We have classifiers about the intended application. Then we have also information about the time period for which data could be delivered, capabilities such as which geometry is observed here, information about the status, is it collecting data or not, true or false, the observed bounding box, you have seen that already, the contacts, who is operating the sensor can be provided, the position, the inputs of the sensor, as well as the outputs. Outputs include then also information about the unit of measurement. Yeah, and that's it. So you have a basic description what is done by the sensor, and also here you can add further information like references to documentation of your sensor, more information about calibration activities or operational history of the sensor, when was it deployed. So lots of different elements you could integrate here, but that really depends on the domain you are working in and the requirements that you have in practice.
Sorry,
Yeah.
How do you see this related to the environment monitoring facilities of the Inspire? Because there seems to be a lot of overlap on this kind of definition and the definition. So, do you think that there should be some recommendations on which data should be in a sensor description and which should be provided by WFS using the DFC?
Okay, Michael? Yeah.
Well, you're referring to the description of the station, basically, right?
The station and the observable properties. And also the metadata about the process.
I mean, in general, any work that we do with the SOS and on the technical data should be closely related to the data model side. So basically, we have the framework document, C2.9, on observations and measurements, 4.5, and that we need to have a look at again to see whether, let's say, which of
Perhaps what's also important is that we do not prescribe a specific schema you have to use for these metadata about the station. So SensorML is one suggestion. In the technical guidance update, I think we do not prescribe that it has to be a SensorML. We just refer, I think, to the data specifications, what are the appropriate formats, because depending on the domain, there may be other approaches. I know in hydrology, they are sometimes relying on O&M measurement processes, and you could also return that through the SOS in the described sensor operation. So that does not replace some other existing specifications how to provide these metadata. You could link that. You could, even if you have other services available providing these information already, think about just returning a reference in that response here, pointing to that other service where the description could be returned.
But it's important that if there are guidelines in the data specs, then we point to the appropriate guidelines. That's one option to use.
Yeah.
Yeah, because the data providers don't want to do these twice.
No. No. But that has been considered here, that we do not require you to do something new. Okay, so that's it, I think, with our example request. Do you have some questions on how to interact with the SOS? You can also try that out at home. So we have provided you the URL. You will also get the sample example requests. You will also get the URL of the test service. All the slides will be put on the website so that you can download it after the workshop and do these experiments at home. And if you have any questions, all three of us would be happy also to answer any questions that you have by email or direct contact. Okay, so then see. Just need to save something. Okay. One next thing I would like to show you is some example of client applications. I already started to shortly introduce one client in the last session, but now we will have a bit more comprehensive view on different types of clients, and we would also like to show you what you can do with these data as soon as you have provided that through an SOS server. It doesn't make sense to just have the server. You also need some tools where you can work with the data to have a benefit of that. And the benefit is really that you should be able to get the data integrated into different applications. Sometimes you may have to add SOS support in existing software, but as soon as it is there, then you would benefit from the sharing of data. So one existing client is the 52 North Sensor Web Client. That's based on the Google Web Toolkit. A short demonstration. So switch off the Zoom. Okay. This client allows you to connect different SOS servers, put the data on a diagram, show the locations on a map. Here we have also some capabilities. This morning someone asked for the provision of tidal measurement data. This is one example from the German coast. You can access data from a water level measurement station all along all German waterways in the coast. That's one measurement every minute. And what you can see here, the latest one was from this morning. There should be now newer ones, and you can really browse through different data providers offering their data. This is an example from the hydrology domain. We could integrate other data providers. Switch this a bit. So like the CSIR from South Africa who are operating a service. That's some data from Sweden. Then We could also look at a service operated by the BFG, the German Federal Hydrology Institute, about discharge data. We have air quality data from Belgium. For example, we can select a station. That's wrong. Yeah. Check. So we can go for ozone. Load the data. Takes a few seconds. Change the color. Oh, no, red is bad because that's always there. Blue. So what you can see here now, we have loaded the data. A second for update. You have the stations in here on a map. You can integrate that web map service, for example, and then you can select data from different providers. Here we have Belgium air quality data. It's from today, 11 o'clock, so very recent data put together with water level measurements. From a thematic point of view, that doesn't make sense, but just to show you that you can combine data from different domains using the same standard quite easily to put that together. Let's see who else is there. I'm not sure. EFAS. That was about.
Flood alert.
I think at JRC or
JRC,
yeah.
yeah.
So yeah, I think they also have set up a SOS server together with the ECMWF. ECMWF also operates a SOS server. ECMWF is the European Center for Medium Range Weather Forecast. They are providing predictions for weather forecast, for discharge forecast for rivers on a worldwide level. At the moment, that's still in development. They are just offering a very small test data set, but that's available. Then we have the GRDC, the Global Runoff Data Center. That's an institution at the Federal Hydrology Institute in Germany with a mandate from the World Meteorological Organization to collect hydrological data on discharge data on a global scale and share this data. Here we are working together with other server implementer, with the Kisters, a company in the hydrology domain, working also based in Germany. They are also setting up a server for that. There we get discharge data for sometimes more than 100 years. So what you can see, there are really lots of different sources you can access, different domains, and as long as they are using the same interfaces, you can really share this data and put that into the same clients. So let's go back to the presentation. So that's this client, again some further demonstrations. Then we also have in place a so-called SensorWeb Client REST API. We have seen this big client, and we had questions from several people who would like to build their own SOS clients. So what we did is we spent quite some work to harvest the metadata from SOS servers, to have some logic internally to create nice menus where users can select the available data. And in the end, we decided that there's quite some interest by other people to use basic functionality of this client, and we provide that through a REST API, which encapsulates other SOS servers and makes them easily accessible. That was a result of the European EO to Heaven project, and is also now published as open source software. And there you can browse through such a service. You can ask it for stations, for time series. These are the main resources you can get through this REST interface. And then you can browse through the phenomena, the features, the offerings, categories, procedures offered by different SOS servers. So just a pointer for you that you can use this also for having a very fast approach. You just need to configure in this API a new SOS as a data source, and then it gets available through this REST interface, and you can build other applications. One example that we have are these pre-rendered diagrams. One use case for this is you configure your SOS into this REST API, and then as soon as you have set this up, you can, for example, put a specific URL into your homepage of your organization, and then you get always pre-rendered diagrams on the entry page of your organization providing some latest data, and you do not have to care about rendering. You just need to know there's an SOS, I configure it into the REST API, and then it provides me this added functionality on top of SOS servers. Yeah, this client has, this API then also offers you, for example, JSON. If you are building mobile applications, you can use these JSON formats on your mobile phone. This REST API delivers you JSON from SOS servers, and then you can build very lightweight and easy to use applications together with your any device basically. Then another project from partner company from Contera is a MapApps SOS client. That's a product they are working on that's quite intensively used on some of their customers. And they were investigating now also to use the SOS as an extension of this MapApps framework. And what they have in place is a prototypical implementation of a SOS connector, integrating that also into their framework with map and diagram visualizations. Here you can see some examples. This is a map view of postal stations. This is an example in Wilhelmshaven. And then you get such a nice overlay with the time series. You can also add, perhaps a bit hard to see for some of you, some reference values like the average water level, the usual maximum water level at that area. So you can nicely compare that with statistical data from the past. They also have some tool for exporting the data as CSV. If you are working with some colleagues who would like to look at the raw data, they can get the CSV file exported from the SOS. You can share that with your colleagues and also make that available to others. And a nice feature is also to have some kind of situational awareness. They are connecting to an SOS server to get the latest values. And then depending on the current value that is measured compared to some warning limits, they can color code the map to, for example, red means that there's a high water level. I think purple is also quite high. So they can, that you can, on one look, can see how's the situation in my area. I think that was taken during a storm in fall last year in Germany. Then another thing which is quite popular is SOS for R. R is a very popular environment and programming language for statistics and visualization. And this SOS for R package allows you to connect to SOS servers and load the data into R and use it for further statistical analysis. That means you can access the data and apply any of all these different algorithms you have in R on these data and analyze it, create some nice visualizations, and it really opens up a new world of analysis tools for sensor data. Just provide the data for an SOS, you can use the R connector and then get the data in there and do your real work with it. So here are some examples. This is an inverse distance weighting interpolation of air quality data. This is again a time series plot created by R based on this SOS for R connector. Also that is open source software and could be used by you if you like. And then I already shortly introduced this JavaScript client. This is one project which is quite recent, and for those of you who were not there this morning, what I would really like to show you is the benefit of interoperability when you can access data from different organizations across borders at the same time. So let's start to select some data from Belgium. So we are now looking at air quality data. Belgium has such an SOS server running for, I think, 1 or 2 years now. We can just select a station, and then we get an overview which parameters are measured at this station. So you see quite a broad range: NO2, PM1, SO2, NO, PM10, carbon monoxide, ozone, and so on. And you can also directly see the latest measured values. So all more or less from today at 11 o'clock. So let's select ozone. You can say OK. So now we have loaded data from Belgium. That's basically, yeah, new real-time data from today. Then, next step, we want to compare the situation in Belgium with the situation in the Netherlands. For that purpose, we just need to choose a different data provider. Now we choose an SOS running in the Netherlands. That's this one here. So that's really running in Amersfoort at GeoNovum. The other one is running in Belgium, I think somewhere near Brussels, but they are using the same interfaces. So let's check somewhere in the Amsterdam area. Let's take this one. And here we again have lots of different observed values. We have benzene, carbon monoxide again, and here down here we find ozone. They are still in the process of feeding new data into their SOS, so they are not yet up to date, but here the latest data is from the 27th of May. So let's select ozone again. Okay. So, and what we get as a message here is no data available because we are here now in June. We saw the latest value is from May. What we can do is we have this function jump to latest value, and now we are jumping back to an area or time period where data is available, and now we get the data. To make it a bit more visible, we change the color. So we have the Dutch data now in red, and this, yeah, let's say green is the data from Belgium. Then, just recently, the team from Sweden also added an SOS server. So we can also have a look at their data. Let's go again to the map view, select another data provider, and it's this one, EVL NV NRT SOS. And then we have stations from Belgium. It's a bit more cryptic because they are using identifiers for the air quality data, which are corresponding to the e-reporting guidelines of the EA. And in this case, phenomenon 7 is corresponding to ozone. So we are selecting ozone, and now we get these stations for which data is available. And now let's select this one. We have that SOS is not as populated as the other two, so we have to be a bit more careful which station we are selecting. And we see we got some data. Let's change the color. So they get blue. So you can see here we have this blue line with air quality data, ozone data from Sweden. And you can see Sweden and Belgium, it's quite similar. Sweden is a bit more distant from that, so they have a different way how the values are developing. By the mid of this week, so I will have another presentation about SOS and Inspire on Wednesday. We hope to have also an SOS published by the EEA available. So the European Environment Agency is working also in this field very intensively. They are now getting through the e-reporting process lots of air quality data from its member states in order to publish that again. And they have set up an SOS server which should become available or has become available at the end of last week. And at the moment, I just wanted to have this demonstration over so that my colleagues in Münster can take the server down to configure the new SOS in. And that should be running on Wednesday with the EA. And then we would have even more air quality data available in this way. So what you really can see is, if you go for such a standard, you can do not have to care where is the data located, who is the provider of the data. As long as you are following a common standard, it's quite easy to integrate that. And as you can see, that's not only about air quality. Air quality is a very fast progressing domain at the moment because there's this e-reporting directive in the background which makes people look more into this technology. But I already mentioned hydrology. Let's take the Wupperverband. They are a local authority in Germany. They are providing other types of data, but also air temperature, for example. So that's from the 12th of, oh, that's a bit old. Okay, let's try that. So we get the message, no data available, jump to last value. So we get air quality data from Wupperverband, a regional authority, and we can put it in there and combine that as well, in this case with air quality data from Belgium. In fact, it's quite interesting. You see when the Belgium and Wupperverband, also the Wuppergebiet is not too far away from Belgium, you can see some correlation. The temperature on these days was quite high, and so was the ozone concentration. So you can see that correlation. It seems that there were similar conditions in Belgium and in the Wupper area at that time. So you can really take your data from different sources, do new analysis, and yeah, benefit from interoperability on a European level or even global level if you look at data like GRDC coming through GEOS. Okay, that's it with this client demonstration part. Before we continue, are there any questions? Okay, so now I think we have also prepared some discussion questions for you because we wanted also to get not only yeah, us presenting all the time what we think is available and what should be done. What's very important for us is also to get some feedback from your side about your current situation, if you are a data provider, what would be your requirements so that we can also make sure we will deliver an open source package which you could use for delivering your data. And what we also would like to know a bit more is, yeah, what are your requirements regarding the provision of data? So who would be your customers for such data? Do you want to make such data publicly available on a limited scope for certain scientists or on request? So is access control an issue for you, for example? What would be the requirements regarding which applications do you foresee that could use such an SOS? So you have seen web-based applications, you have seen R. Are there any other applications you are thinking about which yeah, would benefit from connecting to SOS service? So,
that's something that this discussion is not limited only to this workshop which we had at the beginning. There is a web space which is established within the maintenance and implementation group for the Inspire. So this environment where we can interact, we can share ideas, there will be the resources available. We're all strongly, we will strongly recommend that those of you who are interested register within the pool of experts so that you can get access to the web space and take advantage of all the management opportunities. Looking at this work there together. Maybe we can, yeah, we can show the what platform which we're using.
So maybe a quick question. Who of you knows what the maintenance and implementation group is? Me? Thumbs up. Okay, not everybody. The pool of experts, who knows about it? Who's already registered? Okay, so basically what we have in the maintenance and implementation work, we basically have this commission expert group, it's called the MIG, that basically has nominees from each member state to discuss what should be the work program and what should be the things to be addressed in maintenance and implementation. We have a web space for that. I can just show you. Oh yeah. Thanks. It's a bit cryptic. Okay, so this is basically just a collaboration platform that has a wiki and issue trackers, and all the information on there, well, almost all of it is public. So if you're interested in anything that's going on in implementation and maintenance, this is the place to go and to see what the different groups are doing. And you can see that there are a number of different projects. and we have one that is on the download services technical guidelines. And if you go on the wiki, you will see that there's not a lot there yet. We basically had one workshop in April where some of the work was presented and discussed. We will upload the material that we have from this workshop here as well. And this will also be the space where once there is a new subgroup, this group will be sharing and discussing things. But again, all the information and all the discussions will be public. So if you're interested to see what's going on, this is where you can go. The other thing I wanted to show you is the Inspire website. If you go on the left here, there is a tab on implementation and maintenance that explains a bit about the framework, about the groups, and so on. You can have an overview of what the work program, the different actions in the work program is. It also has a number of links to the collaboration space. And then there is what we call the pool of experts, which is basically a big database where anybody who wants to work on or is interested in following the maintenance and implementation can register themselves, indicating their areas of expertise and interest. And you can also use the search functionalities. For example, if you want to see who has been, who is an expert in download services, you can go and find the people that have registered their expertise in download services. And you can also filter by countries to know what's going on in your country and so on. So if you're interested in following up the work, maybe even getting involved at a later stage, I would recommend that you register in the pool of experts. There are no strings attached. And we will basically use this pool to inform experts about what is going on, and if we're trying to find members for the subgroup to work on this topic further, to do the testing and so on, we will use this this pool to find people that could help us with this. Yeah, and if you want to know who's your MIG representative in your country, you can go here and find that out as well. That's basically just to give you a few pointers.
Okay, so we will include that URL also in the documents you will find on the wiki. Okay. Okay, so now it would be interesting for us to see if any one of you has some ideas on the questions we have presented. So who of you perhaps is thinking about providing or would have to provide any access to observation data? Is there anyone who has perhaps some concerns about publishing the data or questions how you could proceed? So we would be happy to get any feedback on that. Okay, so for example, what would be one of the biggest blockers for you if you have a big data set to publish that through an SOS server? Or is there, could you start immediately providing the data?
I'm not a data provider. Consultant, but I think the biggest cost today would be to have all the data. They have the data, of course, but they have to do it into the SOS.
Okay, so
I think that I think they could see that as a
yeah.
time and cost.
Yeah. Okay, that's a good question because exactly that was also addressed now. So, for example, if you have an observation database with the solutions built in that project, you could just create a mapping and let your existing sources intact as they are already. So that could be quickly solved. Yeah, but that's work of 1 or 2 days.
This importer, which is a very nice tool,
Yeah.
you can do this interactively and with really simple descriptions, the mapping.
Yeah. Yeah.
For instance, a CSV
Yeah.
file or some other.
But you are right. So important thing we have to provide also in this project is some further guidance, how you could create such a mapping, and also perhaps provide some examples from which you could learn. At the moment, it's something we are mainly doing for our customers, and we see it's fast. But I think that's really important to do that also for include that into the resulting documents describing how you could do that in the end.
Maybe a question?
Mm. Mm. I think that relates mainly to many services in the field of Inspire. I think like geographic features, there you also have the risk of single services being down and not available. But I think that's something one has to consider.
No, we inevitably raise the expectations when there is a good service running, and there are a lot of things that potentially can be not being available all the time.
Mm.
I think we should live with it and realize the really good value added
Yeah.
of having the service and being able to interact. And on the question of integrating from different sources, there's also the opportunity, if there are the services, to really, really easily harvest information. And then connect to some sort of, go to some aggregation and create a meta,
Mm.
service on top. When we did try some tests with Belgium, it's really, for several days of work with out-of-the-box open source technology, we were able to visit every hour their service, get the observations which we really needed, and then store in another database. So potentially this can be combined with other applications, a bigger
Mm. In fact, these standards make it even easier to make such backups.
We don't really need to study what the infrastructure that we're dealing with. If we only know the specification of the standard, then we can immediately start interacting with it.
Any other questions to the data providers in the room? I mean, is there a general move in your agency to actually open up the data like data provider, or is licensing and data access, open data, another issue?
Mm.
Because I mean, things like air quality, and at least in some regions where the air quality is not so good, it can be, I imagine it can be politically tricky, or maybe not wanted that you can actually go and see what the air quality is everywhere. I don't know.
Also a question about, do you have perhaps liability concerns? So we have some customers who are a bit hesitant to provide all the data, as for example, if people build warning systems based on these data and then there's a gap or some wrong measurements, they prefer to keep the data close, because then no one can do anything with them and there's no risk that someone does something wrong, which is due to the fact that there was perhaps an error in the data collection process. Is that something also you have been thinking about?
I wonder if the data providers are already using some kind of interfaces for sharing the data, or is it just the SOS or are there no kind of online access to the data at the moment? So that also may be some kind of barrier to cross, that you do at least some kind of online access. I don't know. So are you already providing in some format or some using some API outside? So it's kind of ordering.
So
I
that
think that's interesting. When we have a show of hands, who is already providing data online in one form or another, even through ordering process? And
Who has the data but who is not?
I think that could be an interesting survey to do, maybe. Also in the scope of that.
okay. So any other questions or remarks you have regarding the SOS for Inspire, or this idea of having these interoperable interfaces that we have shown? Okay. So otherwise we could give you one further example. For those who have been there in the first session, it's maybe a bit similar, but now I would like to go in some example deployments. So there you can see how have other data providers worked on sharing their data through the SOS interface, and that you can see a bit more how could that work in practice. So the first one is Belgium. It's IRCEL. They are responsible for air quality in Belgium, reporting that also to the EA. And they are using the quite old version of the 52 North SOS, version 3.x, which has been set up on top of an existing PostGIS database. So they have already their database model in place, their database with all the measurement data, and they just took our SOS out of the box, looked at our database model, our default database model, and just decided, okay, we do not want to touch anything on the code. We do not want to touch anything in our database. What we will do is to provide some additional views to our database, which are following the basic data model of the 52 North SOS. So they emulated somehow the way how the default database model of the 510 SOS looks like, installed the SOS on top of these views, and then basically got it running. So that was a very fast process to set this up. And what you can see here, we even accessed a couple of minutes ago data from this service. So another example is the European Environment Agency, the EA. They are following a completely different approach. So they have installed an ArcGIS server SOS extension that is put on top of their existing air quality database. This SOS extension has specifically been enhanced for supporting the e-reporting schemas required by the directive on the e-reporting of ambient air quality to the EEA. This is at the moment in the final phase of deployment, so the URL has been published last week, and we are just in the process of integrating that. And here you see you can also use existing technology stacks like ArcGIS for sharing your data. In the moment that is limited to the, or focused on the e-reporting of air quality, but such an extension could also be adjusted to meet other thematic domains that you have. Here's one view of the data flows. So you have the member states delivering the data to the EEA in form of O&M documents. These documents follow a data schema defined by the e-reporting directive. This data flows as O&M in here into the EEA infrastructure. There are Python scripts in place to validate the data, to check the data, consistency checks, check that all elements are present in the correct way. And then the data is inserted into a Microsoft SQL server. There all the observation data is stored. And then you have the ArcGIS server with an SOS extension installed here, and then it provides the data to data consumers, and one of the first data consumers will be this client that we have shown, where you can then combine this data from the EEA with the data also served by the member states. Then Pegel Online. Pegel Online is a service operated by the German Federal Waterways Administration. It provides water level measurements for all federal waterways in Germany. It's not only water level, also some meteorological data like wind speed, especially at the coast that is relevant. And here we have a slightly different scenario. We have a proprietary SOAP service which provides access to the database. So their database is really behind lots of firewalls, not really accessible. And their option was they didn't want to have another service accessing their database. They just wanted to have us to use their SOAP service. And then we were contracted to build a proxy which is able to understand SOS requests, translate these incoming SOS requests to the format of their internal SOAP service, ask the SOAP service for the data, and then return the data. And the data which is returned here is then again translated by this SOS proxy and returned as standard conforming O&M document. So that's another workflow if you have more restrictive infrastructures. A similar approach was for testing purposes also implemented at Rijkswaterstaat in the Netherlands. You could go for such a way to share the data. Then we have the Water and Shipping Administration in Northern Germany. There's a central data management unit. They have some long-time time series data like water level, tidal streams, salinity, oxygen concentration. And they are using also the 5to N SOS. However, in their case, the decision was made that the easiest way was forward, because they were using the 3.x SOS, to have an adjustment to the existing Oracle database, so to modify the database access layer a bit in the code. And then you have this way for accessing the data. And you see here the stations. So in this case, they are working with the data and providing this data. What is also interesting is on top of this SOS, you can deploy further services like eventing services, which are not yet in the scope of Inspire, but are also another way how to use the sensor data. In that case, they are at the moment working on a system for continuously checking the salinity in the Elbe River, because what you can see here is the Elbe River is a very large river, at least until Hamburg. And you have tidal effects bringing salt water from the North Sea, bringing that, in a case of high tide, into the Elbe River. And farmers along the Elbe River can only use the water from the river for irrigation in those periods where there is no water from the North Sea in there, but where you have the fresh water coming from upstream. So they are implementing a sensor event service, which is using data coming from an SOS to filter that against certain alerting criteria, and then building some kind of system where you get SMS messages or email messages for farmers if they can start with irrigation or not. So you can really build some value-added services on top of the SOS and to make use. You could think of something similar for air quality services, monitoring the ozone concentration. You could look at other flood prediction services where you can look at the water level. You can even have more intelligent rules there. You get data, meteorological data from one SOS, hydrological data from another, and then combine that and see if there's a critical wind direction and the water level is already high, then there's a risk of a storm flooding. So you really can put together these different information sources through the SOS interface to build further applications which are a bit out of scope what we are talking to today. But with the Inspire SOS, you could also go the step forward and make further use of your data. So you already have seen the clients, and that's it what we have prepared on the SOS. Alex, would you like to give an outlook also on the next steps regarding other services? You already mentioned that. Or
just to maybe mention the other thing that we need to explicitly comment that we can actually leave the door open for other solutions from the perspective of the Inspire download services. So in the technical guidance update which we have proposed, there is also the opportunity to have implementations that are hybrid. So we can basically combine one solution which is Atom for one bit of that satisfies the predefined access download service. Then we can have, for instance, SOS for the direct access. So we will satisfy this flexibility where the different solutions can coexist together, so that we deliver really good content to our users. Something else, I don't know what's the situations for those of you who have services, if you have already implemented WFS, for instance, it would be interesting to also combine WFS plus SOS, the WFS being handling the static part, the static data, which doesn't really need an SOS because it is considered to be the same, then the SOS handling the dynamic part. So we ensure that such guidance, such advice is being provided to you, so that we have a really flexible, nice solution. What I just want to mention is for the way ahead, what we will be looking at is basically, yes, two standards. One is the table joining service, where we will be dealing with another OGC specification, very similar to the one for the SOS. Table joining service explicitly being created for the purpose of handling, linking together statistical tables. Did this work? We want to go ahead again with the same approach. We will be checking for solutions on client side, on the server side, and we would like to basically go ahead the same way. The other standard which is really interesting for us, web coverage service, as you see, the work for SOS is featured on observations, which usually the representation in space is either, in most cases, would be point features, but then we can also have some other geometries, but we can, in terms of features, we can consider those as vector features. Then the web coverage service we want to look at in terms of handling also raster data, which is these are the other candidates for Inspire
download services. So also worth noting, if you want to, if you're interested in this other work, just let us know through this pool of experts, and we can do those things together. So this is basically the direction in which we would like to be going. If you have any comments on that already under suggestions, we would be really glad to take that and discuss further. Any comments, any other ideas? What do you think as providers, as users of data, for Inspire, for observational data, that can make sense for the way ahead? Is there anything? No? So maybe, yeah, we conclude, and yeah, we can.
We are through with our program, and we can conclude the workshop for today. On Wednesday there will be a similar presentation in the conference, and yeah, we would like to